Okay, a 2.5 millihenry air cored inductor is connected to a signal generator set at a frequency of 550 Hz. Calculate the reactance of the inductor. One thing I'd just like us to note at the moment, this is an air cored inductor. So that means it's a hollow coil, a hollow solenoid, air cored. Which means you could put an iron rod in it, but we'll come back to that later perhaps. So, calculate the reactance of the inductor. Let's check again our formula. The reactance of an inductor. Here we go. The inductive reactance. That again is the impedance within an inductor. The quality of the inductor which restricts the flow of electricity, reactance. So remember, we've got two types of reactance. We've got the reactance within an inductor, and here the reactance inside a capacitor, and then we've got the resistance of the resistor, and all three of those will combine together later on to be impedance. So let's take our equation back here, calculate the reactance of the inductor. Here's our equation, XL, inductive reactance is equal to 2 pi FL is equal to 2 times pi times frequency of 550 Hertz times inductance 2.5 times 10 to the negative 3, which should be 8.6 ohm. And remember, units for reactance is always ohms, similar to resistance. Explain two ways in which the reactance of the inductor could be increased. Okay, let's have a look. Here's our equation. XL equals 2 pi FL. So the inductive reactance is proportional to frequency. So if we want to increase the reactance, we could increase the frequency. If we increase the frequency, double the frequency, double the reactance. We could also increase the actual inductance itself. And I mentioned before it was air cored, so we could insert an iron rod in there, an iron core, increase the inductance by inserting an iron core. And this is actually how some variable inductors work, by having a coil and an iron rod which can be put in or brought out of the inductor, and that will change the inductance of the coil. Explain what would happen to the reactance of the inductor if the frequency is reduced almost to zero. So let's have a look again. Our equation, XL equals 2 pi FL. What happens to the reactance if the frequency drops to zero? Frequency tends towards zero, then the reactance would tend towards zero. Reactance would tend towards zero. And note that's the opposite to what happens to the capacitive reactance. As the frequency drops towards zero, the capacitive reactance increases to infinity. They've got opposites. And that would make sense when we think of it in terms of physics principles. As the frequency drops to zero, the frequency tends towards zero, then the rate of change of current would tend towards zero. And from our equation of the induced EMF equals negative L delta I over delta T, as the rate of change of current drops towards zero, the induced EMF drops towards zero as well, which suggests that the impedance is dropping to zero. There we are.